The other week I came across these super interesting and addictive problems called word arithmetic in a logic problem book. And I'm going to give you guys some advice on how to solve these. Each letter represents a one-digit number between 0 and 9, and none of them repeat. So using logic and algebra, we can actually solve for all 9 variables. I'm going to go through the steps that I used on this problem here. So first piece of advice, use a pencil. You will need to do some erasing. And my first thing that I always do is rewrite the problem onto a large blank piece of paper. Be sure to give yourself plenty of space. As you're writing, you may already notice some things. For example, I have just written the same word, ion, and this tells me that I have to have multiplied by 1. So the letter O equals 1. Speaking of the letter O, this is a common mistake on these, is that it's really easy to mix up the letter O with 0. So I make sure that I write them differently. My O's, I put a loop, and the zeros, I put a slash through it. Another tip that I usually do is I write the numbers and letters in a list on the side of the paper. That way I know which ones I've already solved for. As I figure out the letters, I go back to the problem, erase them, and replace them with the number. So here I'm going to go ahead and replace O with 1. When looking at the subtraction, I always start with the variables furthest on the right because that's going to determine how the variables on the left are used, whether they are, whether we're going to borrow from those or not. So I usually write equations as I go. Here you see n can't be 0 because then p would also be 0, and we know each number only has one variable associated with it. So p is not 0 and p also can't be 1. Also, n can't be 1 because we already have O equal to 1, so that means that p can't be 0. Looking at the next subtraction grouping, I see n minus 1 equals I. Since n is at least 2, because it's not 0 or 1, we know we won't have to borrow from the next column. So this tells me that n is 1 more than I. I have a relationship between 3 variables now, so I'm going to create a table to explore the possibilities. I can't be 0, since that would make n 1. I can't be 1, so n can't be 2. But I equals 3 is a possibility. That would make n equal 4, and p would be 11 minus 4, which is 7. And then I'm going to just complete the rest of the table that same way. If I equals 5, n equals 6, and that would make p equals 5, but we already said I is 5, and the 2 variables can't have the same value, so I'm crossing out that possibility. So here are all my possibilities for these 3 variables. Moving down to the third subtraction, I see e minus 1 equals c. This time there's no reason to think e can't be 0, so I need to consider 2 cases. And when I have these multiple cases, I like to work through them, and then hopefully one of them will come out with a contradiction, and then I'll know that's not the correct one. So I'm moving to the left. I see that I minus r equals 1. I can operate under the knowledge that I is not equal to 0, so if I've borrowed, I'm working with I minus 1. I've worked through these and still don't have a contradiction, so I'm going to go back up to the problem and mines for some more information. I notice that L and 1 have nothing between them. Since O is 1, L cannot also equals 1, which means the B had to borrow from the L. And so L equals 2. It also means, since we had to borrow, that C is greater than B. So let's come back to that after we replace all the L's with 2. When I do that, I notice the top row now says 1 minus 1 equals B. So B equals 0. That means E is not equal to 0, so I can cross out that case. I have some new information about the relationship between C, I, and E. So I add C and E to my table. Now I'm seeing some contradictions. No variable can equal 10, so I can cross those out. No 2 variables can be the same, so I can cross those out, and I'm down to 2 options. Back down in my cases, I see a contradiction. I already know B equals 0, so I cannot equal 0. I cross out that case, and I know the last one is true. So using this information, I add R to my table. The first option would set R equal to 2, but I already know L equals 2. So I'm left with only one option, which gives me my answer. And when I fill in the variables for the numbers, I notice the only one I'm missing is D. My final answer here should spell a word, in this case 2 words, bold prints. So I hope you enjoyed this video.
Proportions. Numbers.
Exponent.